Hmm. So hello everyone. Today we are going to start a new chapter which is improper integrals. Now till 12th standard we have studied integration which is integrals. So till now we studied integration which is definite integrals and indefinite integrals. We already know that what is definite integral. If we have an integration of some function f of x, just a second. If you have integration of some function f of x, and if we don't apply any limits into it, then we have some answer, it may be some answer, and then we put a constant of integration which is c. This integral is indefinite integral. Now in the same function, if we put some limits, that is, let us say that this function is been integrated from limit a to limit b of x, then we get a finite answer here. Finite answer. So this is called as a definite integral. Okay. So what are we going to study is improper integrals. So let me first explain what is improper integrals. Suppose we have a finite integral, means we have been given minutes a and b. Now what if there is some limit? Now what if one of the limit is infinity? Suppose we have function f of x. Now we need to integrate it from limit some, let's say that it is a, and then we have to integrate it till infinity. Now obviously when we try to solve it, we'll get some answer here of this integration. Then we need to apply the limits. While applying the limits will be from a to infinity. Now if we put limits inside this answer, which may, whatever it may be, so if we put, let us say that answer would be x square or x square plus x cube plus x raised to 4 by 3, just for an example. If we apply this kind of if our answer of integration is this, and if we apply limits in this infinity to a, then if we put infinity in place of x square, then it would be infinity square plus infinity cube plus infinity raised to 4 upon 4, which would tend to again infinity only. So this is not a proper answer that we need to find. Okay, so this answer is not defined. So to solve this problem, the concept of the concept of improper integral was developed. Let us see what was that. Suppose we have a function integration of a function f of x. Okay, and it is been integrated from a limit a to, let us say, to some limit infinity. Okay, now how to integrate this function? This is also called as type 1 improper integral. This is also called as improper integral of type 1. Okay, so if this function f of x has been integrated from a to infinity, how to solve this integral is we take the limiting condition of this integral. Means we assume that there is some number, let us say it is b. So let me show it. If we take this integration, that is, it is from a, then we take this infinity to some proper number, let us say it is b. Okay, now what we'll do, this b is tending to infinity, so we apply the limiting conditions here, which will be limit, this infinity. Okay, we have chosen a number which is very nearer to infinity, which is finite. We have not gone till infinite, but we are gone to a finite number. Now what will happen, this b would be tending to infinity. So this limit b tends to infinity, f of x dx. So this is basic formula, or we can even say formula, or even say the concept of type 1 improper integral. What is type 1 improper integral? The infinity would be in the upper limit. This is, this is upper limit. This one is upper limit and this one is lower limit. right? So type 1 improper integral has a finite lower limit and an infinite low upper limit. Okay, finite lower limit and infinite upper limit. So integration of some function f of x from a to infinite can be given by assuming a number which is say b. Okay, and this b would tend to infinity. You can clearly see from it this b is tending to infinity. So we write b here and we take the limiting conditions. Limit b tends to infinity f of x dx. Let me show this question. Illustrate this view by an example. Suppose we have example, we have integration 1 to infinity 1 by root x dx. Okay, now we know this is an improper integral of type 1. Why? How can we get to know this? Because its lower limit is constant and its upper limit is infinity. Okay, so now we assume some number b instead of this. Okay, we assume some number b in place of infinity such that b is tending to infinity. So we write b here instead of infinity, and this b is tending means limiting conditions of b are tending to infinity. मतलब b के वैल्यू है वो infinity तक, मतलब b हमारा infinity को tend कर रहा है, b की वैल्यू infinity से नजदीक होती जा रही है. b is tending to infinity and the function is as it is 1 by root x dx. Okay, now we know this r integral which we have got is a definite integral. We can solve it by our proper integration methods, which are run till 12 standard. Okay, so let us solve this side. So this will be limit conditions. Limit b tends to infinity 1 by root x means this is 1 by root x. 1 by root x is actually x is to power minus 1 by 2 dx. Okay, integration of x is to power minus 1 by 2 dx is x is to power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. This by the formula of x is to integration of x raised to n only. Okay, x is to integration of x raised to n is x raised to power n integration of x raised to n is, we know that it is x raised to power n plus 1 upon n plus 1, right? So this would be x raised to power minus 1 by 2 plus 1 means x raised to power 1 by 2, and this is minus 1 by 2 plus 1 means in denominator it is 1 by 2. So the 1 by 2 will go up and it will become 2. Okay, so our answer here, let me write it here again. Answer will be 2x raised to power 1 by 2 from 1 to b. Okay, now let us apply the limits here. So this would be limit b tends to infinity 2x raised to power 1 by 2. So let us apply the upper limit first. This would be 2b raised to power 1 by 2 minus 2 times 1 raised to power 1 by 2. Anything raised to power, anything which is in power with 1 would be 1 itself. So this would be limit b tends to infinity 2b raised to 1 by 2 minus 2. Okay, now it's time to apply the limits here. Okay, so we just apply, we can't see any 0 by 0 and infinity by infinity form here. So this is completely a determinant form. Okay, so we can directly place the value of limit inside it. So b is tending to infinity, so we can place infinity in place of b. So this would be 2 times infinity raised to power 1 by 2 minus 2. Now what is infinity raised to power 1 by 2? Infinity is a very big number. So any big number raised to power 1 by 2 would also be a big number. So this would be infinity raised to power 1 by 2 will be infinity itself. And infinity multiplied by 2 means very big number multiplied by 2 will also be a very big number. So this would be again this term, this whole term would be infinity, and infinity minus 2, a big number subtracted from a small number will always be a big number. So it will be again infinity only. So the answer of our question improper integral is infinity. Now there are two concepts here. If we have an improper integral, for any improper integral, if you have any any improper integral, okay, it will have always two answers. One answer may be infinity, another answer may be some finite value. Okay, so this is infinite. So if the answer of our improper integral is infinite, then we say that this improper integral is divergent. And if our answer is finite, then we say that our improper integral or the given improper integral is convergent. So you can see this, the question, our integral question was, our question was integration 1 to infinity 1 by root x dx, and we got our answer as infinity. So this integral, this improper integral, which is of type 1, is divergent. Clear? Now let us take a next example, which is integration from 1 to infinity of 1 by x squared dx. Okay, so we can again see this integral is improper. It is an improper integral. Why? Because it has one of its limit as infinity, and it is of type 1 because its lower limit is finite, which is 1, and its upper limit is infinite. Okay, so the method for solving this question is again the same. We take some number b instead of infinity, which so our integral will start from 1, and it will go to b such that the b is tending to infinity, means limiting conditions of b are tending to infinity, and it is integration of 1 by x squared dx. Now integration, now this is again to be solved by our proper method only, which is so simple. So we solve it. This would be limit b tends to infinity. Okay, so integration of 1 by x square, you know that x raised to n, integration of x raised to n is x raised to n plus 1 upon n plus 1. In this case, it is x raised to power minus 2. 1 by x square means x raised to power minus 2. So it would be x raised to power minus 2 plus 1 upon minus 2 plus 1, which is minus 1 by x. Okay, if you can't see here, I will write it here again, which is minus 1 by x. Okay, so write here minus 1 by x again, from b to 1, means 1 to b. Okay, now we apply the limits here again. This is limit b tends to infinity. Now we apply the limits here. We place b first of all in place of x, and then 1 in place of x. Okay, so this will be minus 1 by b minus of 1 by 1. Okay, so what will it be? This would be limit b tends to infinity minus 1 by b plus 1. Okay, now since again we can see there is no 0 by 0 form or infinity by infinity form or any indeterminate form, so we can directly put the limit of b in this value, in this b. So we place infinity in place of b. Okay, so this will be minus 1 upon infinity, sorry, minus 1 upon infinity plus 1. Plus 1. So this will be, what is 1 by infinity? 1 by infinity means 1 by some very big number. Any number by some very big number will always tend to 0. So 1 by infinity is always 0. So this will be 0 plus 1, which is equal to 1. Now you can clearly see that we got some finite answer. In the previous question, we got our answer as infinity, which was infinite, but here it is 1. Whether it by finite we mean that we get some finite answer. means we can get 0, 1, 2, 3, 4, negative, positive, every integer equation or every fractional number is counted. So we have got our answer is 1, which is finite. So since our answer is finite, we say that the improper integral infinity to it is 1 to infinity 1 to infinity 1 by x square dx equals to 1. So we say that this improper integral is convergent. Till now, since we are concept clear about type 1 integral, in the next lecture we'll see about type 2 integral and type 3 integral. Till then, keep practicing about it, and if you feel any kind of doubt inside it, you can rewatch the videos and you can see this. Okay, till then, thank you. Meet you.